In this video, we want to show that the following statement is true. So if we have a to a power of log of x to base a, we want to show that's equal to x, that's equal to x. And this is just really just one of the properties of logarithms. So let's review the definition. We have the log of some number x to base b. We know the base has to be positive, and we don't want the base to equal to 1. So we can have values between 0 and 1 or greater than 1. And let's suppose this is equal to the number L, which is the logarithm. So L represents the logarithm. So this implies, and it goes back the other way also, that x has to equal to b to the L. So if you have this log expression, you can write it as an exponential, or if you have an exponential, you can write it as a log. Either way. And you use this a lot when you're solving logarithmic equations. So let's get back to this problem then. We want to show that this expression equals to x. So let's do this. Let's say a, the power here then is log of x to base b, or base a, I should say. We want to know what that equals to. Of course, we want to show it's equal to x, but let's call it y since we don't know yet. We have to prove it. So look at this right here as the exponential. Look at this as the exponential. So we go from here to here. So what do we have? We have to have a log. From this we get a log. Okay, so we have it over here. And what's going to be the base of that log? When you look at it here, it's the exponent. And there's the base. So this has to be a. And then this will be the log of what? When you look at the relationship here, this x and this x here. So in this case, it has to be y. This has to be y here. And then what goes over here is the L, or the actual logarithm, which in this case is represented by the log of x to base a. So then from here, what do we know? There's a property of logs again that tells you that if you have a log of some number, in this case y, to some base, and if that's equal to the log of some other number to the same base, those numbers have to be equal. So this tells me then that y has to be the same thing as x. So what have we shown? We have shown then from that a to the power of log x to base a is equal to y, but y is the same thing as x. And that's what we wanted to show. So this tells you anytime you have a base and the power is the log of some number to that same base, so in other words these are the same, then the answer is going to be whatever you're taking the log of. And the corresponding property is also this one. If you have the log to base a of some number a to the x, so if these two bases are the same, then the answer is going to be the exponent here of this base, which is x. And we know, or should know, that a logarithmic and an exponential function are inverses of each other. And that's really where this particular property comes from. If I have f composition f inverse of x, f composition f inverse of x is always x. If I reverse these and write that as f inverse composition f of x, that's also x. And that's where these two properties come from. This one right here and this one right here, which of course is this one here, come from the fact that the exponential and the log function are inverses of each other. Thanks for watching. We'll see you next time.